14 hours ago, something happened that quietly shattered one of the most stable assumptions in astronomy, and almost no one outside the scientific community noticed. At 4:12 UTC on February 23, 2026, the control room at the Atacama Large Millimeter Array in northern Chile confirmed a detection with only a 0.02% chance of being natural. Not theoretical, not ambiguous, a direct spectral signature, and what it revealed was deeply unsettling. The signal was a dense, high-velocity stream of H2CO formaldehyde. Pause for a moment and let that sink in. Formaldehyde is not just another space molecule, it is organic chemistry. It is a foundational precursor in the chain that leads to amino acids and, eventually, life. We find it in warm, crowded star-forming regions where radiation, pressure, and chemistry collide. What we do not find is formaldehyde venting in concentrated jets from a lone object drifting through the freezing vacuum of interstellar space. ALMA's Band 6 receivers detected the transition line at exactly 218.2 GHz. This was not a weak trace buried in noise. The signal-to-noise ratio was 50:1. In observational astronomy, that is not a hint, that is a shout. The object responsible, known as 3I, Atlas, was sitting nearly 1.8 astronomical units from the Sun, far beyond where complex organic chemistry should be active. And yet, at that distance, something had opened a vent. Not water vapor, not carbon dioxide, but a stream of highly concentrated formaldehyde moving at roughly 400 meters per second. When astrophysicists examined the spectral lines, one detail immediately stood out and refused to let go: the purity. Natural cometary outgassing is messy by definition. Water, ice, dust, silicates, carbon monoxide, all mixed together in chaotic proportions. But the signal from 3I, Atlas, was different. The H2CO lines were sharp, isolated, and almost unnaturally clean. That detail matters because formaldehyde is fragile. Ultraviolet radiation from the sun breaks it down quickly. In open space, it should not survive long enough to form a coherent structure. Yet ALMA's data showed a plume stretching more than 4,000 kilometers behind the object. This was not slow sublimation from a warming surface. It looked like a controlled discharge. Even more disturbing was the timing. The vent activated precisely as 3I, Atlas, crossed the frost line, the region where volatile compounds transition between solid and gas. The margin of error was less than 3 hours. Natural processes do not obey schedules that tightly. Nature fluctuates. This event was synchronized. To understand why this detection is so disruptive, we have to rewind the clock. 3I, Atlas was first flagged by the Atlas Survey in Hawaii on December 12, 2025. At the time, it looked unremarkable, a hyperbolic object passing through the solar system, similar to Oumuamua or 2I, Borisov. Expectations were low. Silence was assumed. That silence ended on February 19 at 14 UTC, when ALMA astronomers searching for simple water vapor instead found a massive spike in the 1-3 millimeter band formaldehyde in quantities no comet should possess. One anomaly might be dismissed. Two raise eyebrows. What followed crossed into territory modern astronomy has never documented before. Within 40 minutes of the ALMA alert, the European Space Agency triggered an emergency target of opportunity observation for the James Webb Space Telescope, and at 16:30 UTC, Webb locked onto 3I, Atlas. What its instruments saw did not calm anyone down. It made the situation worse. Because the chemistry was only the beginning. When the James Webb Space Telescope focused its instruments on 3I, Atlas, it didn't just confirm the presence of formaldehyde. It mapped how that material was behaving. Webb's near-spec instrument detected absorption features at 3.66 microns that matched high-pressure gas venting, not slow surface sublimation. In other words, this was not ice gently warming under sunlight, it was gas being forced out from within. To verify the motion of the plume, researchers cross-checked the data with the Nobayama Radio Observatory in Japan. Their measurements confirmed that the material wasn't drifting away under weak gravity. It was being expelled at nearly 0.8 kilometers per second relative to the object's surface. That speed matters. It is far beyond what passive heating can produce on a body of this size. 3 independent observatories, working in different wavelengths, arrived at the same conclusion. The venting was active. To appreciate how strange this is, it helps to look at precedent. When the Rosetta mission studied Comet 67P, Churyumov-Gerasimenko, it detected trace amounts of formaldehyde, but always mixed with water vapor, carbon monoxide, dust, and a long list of other volatiles. That is what nature produces, a chemical soup. But the data from Webb suggested that the stream from 3I Atlas was roughly 98% pure H2CO. Chemical purity at that level is rare anywhere in the universe. We do not find pure aluminum in nature. We find ore. We do not find pure formaldehyde ice drifting through space. Seeing a spectral line this clean implies separation, refinement, a distinct source isolating one molecule from all others. And then the behavior changed. On February 20th, the venting stopped completely. For 6 hours, 3I Atlas went silent in the radio spectrum, no plume, no emission, nothing. Then at 2 UTC today, it restarted, but not as a continuous flow. The gas began emerging in pulses every 4 hours and 12 minutes with remarkable regularity. This is where comet models fail entirely. Natural venting follows sunlight. As a comet rotates, different patches heat up, producing a smooth rise and fall in activity. The graphs form curves. The data from 3I Atlas does not. It forms a square wave. On, off, on, off. A switch, not a thermal response. The scale of the discharge makes the problem even harder to ignore. ALMA's measurements indicate roughly 40 kilograms of formaldehyde being released every second. That adds up to tons of complex organic material entering space each hour. For this to be natural, the object's surface would need to be coated in a massive reservoir of frozen formaldehyde that somehow remained uncontaminated by water ice for billions of years. The probability of that formation scenario is vanishingly small, which forces an uncomfortable question: if this is not natural, what process produces pure formaldehyde as a byproduct? On Earth, formaldehyde is used in resins, textiles, and industrial manufacturing. But in high-energy physics and advanced engineering, it can also appear as a breakdown product of certain exotic coolants. That possibility becomes difficult to ignore when you consider the thermal data. Something on 3I Atlas is getting hot, very hot, and the vent may not be a tail at all. It may be a cooling system. That interpretation leads directly into a thermodynamic paradox. A comet is a dirty snowball. Sunlight warms it. Ice sublimates. Gas escapes. The process is gradual and externally driven. But the surface temperature of 3I Atlas is currently around minus 120 degrees Celsius. At that temperature, formaldehyde is a solid block of ice. It cannot vaporize on its own. And yet, the gas leaving the surface is measured at nearly 400 Kelvin, more than 127 degrees Celsius. So we are faced with a frozen object emitting boiling gas. That energy has to come from somewhere. There is no sunlight to power it. There is no evidence of a radioactive core. The amount of energy required is comparable to a small nuclear reactor operating continuously. And the vent itself is not diffuse. ALMA's resolution shows the gas emerging from a single point less than 50 meters wide, forming a tightly collimated stream that holds together for thousands of kilometers. Nature does not build nozzles. And once you factor in the velocity of the plume, the implications grow even more serious because at that speed, every pulse is doing more than releasing gas. It is pushing the object itself. It is pushing the object itself, and that is where the situation moves from strange chemistry into active dynamics. The velocity of the escaping gas exceeds the escape velocity of 3I Atlas, which means each burst acts like thrust. This is not theoretical. Astronomers have measured the effect. On February 19th, the object's trajectory shifted by 0.00004 degrees. On paper, that number looks insignificant. In space, over millions of kilometers, it is the difference between a wide miss and a dangerously close pass. This phenomenon is known as non-gravitational acceleration. We have seen it before. Oumuamua showed a weak version of it in 2017, likely caused by hydrogen outgassing. But that acceleration was smooth and continuous. What we are seeing here is not. The motion of 3I Atlas changes in discrete steps. Every 4 hours and 12 minutes, the object receives a measurable kick. The timing is exact. The magnitude is consistent. And when researchers compared the thrust cycle to the object's rotation period, they matched perfectly. That alignment is critical. The vent activates when the emission point rotates into a specific orientation, and notably, that orientation is away from the sunday. A natural comet vents where sunlight hits it. This object vents where sunlight does not. That detail alone eliminates standard thermal models. Combined with the pulse thrust, it suggests something far more deliberate, orbital correction. In effect, 3I Atlas is behaving like a controlled vehicle. It vents, it accelerates, it stabilizes, and then it waits for the next cycle. The chemistry is not random, the timing is not environmental, and the motion is not passive. Each system reinforces the others. The chemical signature adds another layer of discomfort. Formaldehyde may be a simple molecule, but it sits at a critical junction in organic chemistry. In the presence of ammonia and water, it forms amino acids, the raw materials of biology. That raises a question no one is eager to ask out loud. Why would an object travel interstellar distances only to release life precursors into another system? There are two broad interpretations. One is intentional seeding, the other is waste. In industrial processes, formaldehyde often appears as a byproduct of catalytic reactions. In more advanced theoretical systems, particularly those involving organic-based coolants or biochemical synthesis loops, formaldehyde is a common exhaust compound. If 3I Atlas houses a high-efficiency energy system, this plume may not be a message at all. It may simply be excess material being dumped to regulate internal temperature. That interpretation fits uncomfortably well with the thermal data. We are observing a frozen exterior coupled with a localized source capable of heating gas to 400 Kelvin. That requires internal power, not residual heat, not solar input, power. And then the isotopic data arrived. 14 hours ago, ALMA didn't just tell us what molecule was venting, it told us how it was made. Carbon exists primarily in two stable isotopes, carbon-12 and carbon-13. In our solar system, the ratio is consistent, roughly 99 atoms of carbon, 1,2 for every 1 atom of carbon, 1,3. That ratio is a fingerprint of our local stellar nursery. Even interstellar objects show variation, but always a mix. The formaldehyde from 3I Atlas does not. The carbon, 1,3, is almost completely absent. The measured composition is 99.99% carbon, 1,2. That level of isotopic purity is not found in nature. Stars do not produce it. Comets do not preserve it. Planetary fragments do not isolate it. To achieve that ratio, you need separation technology, centrifuges, diffusion systems, or nuclear-scale processing. Nature does not filter isotopes to 4 decimal places. On Earth, carbon that pure exists only in specialized laboratories or inside reactors where isotopic control is essential. Seeing it vented into space, at scale, from a small interstellar object collapses the remaining natural explanations. A shard of a planet would be isotopically mixed. A comet would be contaminated. This material is manufactured. At this point, the freak of nature argument strains credibility beyond its limits. To accept a natural explanation, one must believe that an object formed from nearly pure carbon, 1,2, developed a narrow vent capable of heating gas to hundreds of degrees, timed its emissions to its rotation, and adjusted its trajectory with precision, all by chance. The alternative is simpler and far more unsettling. 3. Atlas is operating, and the direction of that operation raises the final question of this phase of the story, because the vent is not oriented randomly in space. The plume is aligned. Its trajectory intersects Earth's orbital plane, and that alignment becomes unavoidable when you project the motion forward, because in 6 months, Earth will pass directly through the trail it is leaving behind. And that is when the situation changes again. Because intersecting a trail is not the same as observing it from a distance. When Earth passes through that plume, we are no longer passive watchers. We become part of the experiment. The projected path shows our planet crossing the densest region of the released material sometime in late August, depending on how the emission rate evolves over the coming months. This is not speculation. The orbital mechanics are straightforward, and multiple teams have reached the same conclusion. The immediate concern is not impact. The particles in the plume are microscopic, more like a cloud of gas and dust than solid debris. But the composition matters. Formaldehyde is highly reactive in planetary atmospheres. When it encounters ultraviolet radiation, it breaks down into a cascade of secondary compounds, including carbon monoxide and more complex organics. In Earth's upper atmosphere, those reactions could temporarily alter local chemistry. Under normal circumstances, this would be a minor issue. Earth is constantly bombarded by interplanetary dust and solar particles. But what makes this event different is the concentration and the purity. We are not dealing with a diffuse mix of random molecules. We are dealing with a sustained stream of a single compound, released intentionally or at least systematically over months. To assess the risk, atmospheric models were run using conservative assumptions. Even under worst-case conditions, there is no credible scenario where this plume causes direct harm at ground level. The atmosphere is simply too vast and the material too dispersed by the time it descends. That conclusion is solid, and it matters, because it removes the easiest explanation for panic. This is not a threat in the conventional sense. But safety is not the only question. The real issue is information. Formaldehyde is not just a chemical, it is a signal. Its breakdown pathways are well understood. Its spectral fingerprints are easy to detect. When Earth passes through that trail, our satellites, high-altitude aircraft, and ground-based observatories will be able to sample the material directly. For the first time, we will not be inferring composition from light. We will be measuring it in situ. That opportunity has not gone unnoticed. Space agencies have quietly adjusted observation schedules. Several atmospheric monitoring satellites have been retasked to collect high-resolution data during the crossing window. At the same time, radio observatories are tracking 3I Atlas continuously, watching for any change in emission behavior as Earth's approach becomes unavoidable. The assumption is simple: if this object is responsive, it may react to being observed more closely. And then there is the alignment problem. When researchers trace the orientation of the vent relative to the object's trajectory, they notice something subtle but critical. The plume is not just intersecting Earth's orbit by chance. Its emission axis is inclined in such a way that the densest part of the trail remains near the ecliptic plane where most planets reside. That maximizes the likelihood of interaction, not just with Earth, but with any inhabited or potentially habitable world. Again, there are natural explanations for almost any single feature, but the pattern is what matters. Pure chemistry, pulse thrust, isotopic refinement, orbital alignment, now deliberate exposure. At this stage, even the most cautious scientists are shifting their language. Words like anomalous and unprecedented are being replaced with non-natural and technologically influenced. These are not conclusions made lightly. Careers are built on skepticism. Extraordinary claims invite brutal scrutiny, and yet the data keeps pointing in the same direction. If 3I, Atlas, is artificial, then its behavior makes sense. A system venting waste heat and byproducts, a vehicle maintaining trajectory, a probe or carrier releasing material into a target system. None of this requires malicious intent. It does not imply invasion or surveillance. It implies presence. That distinction is important because it reframes the discussion. The question is no longer, is this dangerous, but is this communicative? Dumping a chemically pure, easily detectable substance into a planetary system is a crude but effective way to announce arrival. No language required, no decoding needed, just physics and chemistry. And Earth is about to receive that announcement directly. Which brings us to the most uncomfortable realization so far. Whatever built 3I, Atlas either knows Earth is here or does not care whether we are. Both possibilities carry weight. One implies intention. The other implies indifference. Either way, the crossing will happen, the data will be collected, and once we analyze that material, we may finally learn whether this object is merely passing through or whether it has already completed the purpose for which it was sent. Because what happens after the plume dissipates may matter far more than the plume itself, and that is where Part 5 begins, because once the plume has done its job, the behavior of the object itself becomes the only remaining clue. After the August crossing window, 3I, Atlas is projected to continue inward for several more weeks before reaching perihelion. Under a natural model, this is where activity should peak. Heat increases. Volatiles erupt chaotically. The surface degrades, but that is not what the predictive models are showing. Instead, simulations based on the current venting pattern suggest something counterintuitive. If the pulses continue at the same interval and mass flow, the object will gradually reduce activity as it approaches the sun, not increase it. That is the opposite of cometary physics. It implies that the venting is not driven by temperature at all, but by an internal schedule. And that raises a disturbing possibility. The plume Earth will pass through may not be a byproduct of transit. It may be the objective. Consider this carefully. If you wanted to introduce a specific chemical into a planetary system, you would not dump it randomly. You would release it where orbital mechanics guarantee interception. You would time it so the target planet sweeps through the densest region, and once that task is complete, you would shut the system down to conserve resources. From that perspective, The observed behavior is not strange. It is efficient. At this point, some researchers began running backward models. Instead of asking what 3I Atlas is doing now, they asked where it has been before. By reconstructing its incoming trajectory, they identified at least 2 other star systems it passed through over the last several million years. In both cases, the path intersects regions known to host planets within their habitable zones. The margins are wide, and the uncertainties are real, but the pattern is unsettling. This does not mean those systems were visited in the same way. It does mean the path is not random. Critically, there is no evidence that 3I Atlas slowed down or altered course significantly in those systems. That suggests it was not stopping. It was passing through, releasing material, and moving on. That is not exploration. That is distribution. The term seeding has started appearing more frequently in internal discussions, though it remains controversial. Not because it implies alien life, but because it implies long-term planning. Seeding is not about observation. It is about influence over timescales that dwarf civilizations. Formaldehyde alone does not create life, but it accelerates chemistry. It biases outcomes. In the presence of the right conditions, it nudges complexity forward. A system repeatedly exposed to such compounds over geological time could develop very differently from one that is not. If this interpretation is correct, then Earth is not being visited, it is being included. That realization forces a shift in perspective. Humanity has spent decades scanning the sky for signals, radio waves, laser pulses, anything that looks like a message. What we may have missed is that the message was never meant to be heard. It was meant to be absorbed. Chemistry does not require translation. It operates the same way everywhere. A molecule is a molecule, regardless of who observes it. If you wanted to affect many worlds without interacting directly, chemistry is the most universal tool available. Still, skepticism remains essential. There are unresolved questions. Why formaldehyde and not more complex compounds? Why pulses instead of continuous release? Why now? These gaps matter because extraordinary interpretations demand extraordinary restraint. But the window for ambiguity is closing. Once Earth passes through the plume, laboratories around the world will analyze the material independently. Isotopic ratios will be verified. Trace contaminants, if any exist, will be identified. Molecular chirality will be measured. If there is even the faintest sign of artificial processing beyond what remote sensing has already shown, the debate will end. And then comes the final phase of the encounter. After perihelion, 3I, Atlas will accelerate out of the solar system. Its outbound trajectory is steeper than its inbound path. That means it is gaining energy, not losing it. That gain is small, but measurable, and it aligns perfectly with the cumulative thrust expected from the pulsed emissions. In other words, once it has passed us, it leaves faster than it arrived. That is not how debris behaves. That is how vehicles depart. If the vent shuts down completely after Earth's crossing, if the pulses cease and the object becomes inert, then the conclusion will be hard to avoid. The mission, whatever it was, will be complete. And all that will remain is the evidence it left behind, drifting invisibly through our atmosphere, waiting for us to realize what it means. And that is where the story reaches its most consequential moment, because once the object begins its outbound trajectory, the question stops being what it is and becomes what it leaves behind. As Earth moves closer to the projected intersection point, atmospheric models are already being adjusted. Unlike a meteor shower, this encounter will be invisible to the naked eye. There will be no streaks of light, no fireballs, no spectacle. The particles involved are molecular, not rocky. They will drift in silently, dispersing high in the upper atmosphere, detected only by instruments designed to measure trace chemistry. What happens next will not be immediate. There will be no sudden changes, no instant effects. Formaldehyde is not a toxin at these concentrations, nor is it biologically active on its own. But chemistry does not work on human timescales. It works slowly, patiently, stacking probabilities. Molecules collide, reactions occur, pathways open that were previously unlikely. The influence, if there is one, will unfold over years, decades, centuries. And that is precisely why the scenario is so unsettling. Nothing about this event demands urgency in the way an impact threat would. There is nothing to intercept, nothing to deflect. Even if the object were confirmed, beyond all doubt, to be artificial, there would be no meaningful way to respond. It is already here. Its material is already en route. The only thing left to do is observe and understand.